Welcome back to Mishler Math. Today we're going to write an equation in slope-intercept form for the line containing the points. Let's make it 3, -2, and 5, 7. So there's 2 points, the x and y coordinate for each point, and there's a line passing through those points. And we want to write the line in slope-intercept form, which is, of course, y equals mx plus b. Let's do it the easy way first. Let's start with finding the slope. And remember I said when you're finding slope, take a second and label these things because it'll save you an awful lot of heartache. And I'll tell you why. Yeah, y2 minus y1 over x2 minus x1. The reason is very, very simple. It is so easy to get these things confused. So you got 7 minus a -2. Put those in parentheses. And divided by, let's see, what color did I use for that? There we go. X2 is 5 minus x1 is 3. Now the easiest thing in the world for me to do is put 3 minus 5 over -2 minus 7. I swear, and when you're in a hurry and you want to get the work done and it's the end of the class period or something like that, it's real easy to do that. And the reason I tell you this and warn you about this all the time is so you try to avoid that pitfall. So 7 minus a -2 is 9, because remember that's 7 plus 2. And subtract a negative and it's the same as adding it. And 5 minus 3 is 2. So 9 over 2 is the slope, okay? So that's equal to m. So we got this part of it already. We got y equals 9/2 x, okay? And sorry about that, a little sloppy Mishler math. This is what happens when you do these late in the evening. All right, so 9/2 x plus b, and I'm not going to put a plus there because it might be minus, and so let's just wait and see what happens. So I'm going to use 5 and 7, and these are x2, y2. It doesn't matter. I need an ordered pair. I can use either one of these ordered pairs. So I'm going to do this. I'm going to put this equation, I'm going to go y equals mx plus b, and I know everything in here except the b. So I'm going to find out what b is by just plugging in the numbers that I know about. Now 9/2, okay, goes there. X, what is x? Well, I said I'm going to use this ordered pair, and the x here is 5. And the important thing is to remember I have to use that with this y, because this is an ordered pair. These two go together. If I were going to use these two would go together. These two go together in this equation. So, and the y is 7. So 7 equals 9/2 times 5 plus b. 7 equals 5 times 9 is 45 over 2 plus b. Now for those of you who really are struggling with fractions, please talk to me. I'll give you some resources. You can work on fractions. You're going to have a very, very difficult time in Algebra 2 if you're struggling with fractions, if you don't know how to do basic fractions. I can tell you this, I'm going to make this real easy on you, okay? I'm going to move this up here so I got some room to work. 7 equals 45/2 plus b. I'm just going to subtract 45 over 2 from both sides. And of course that gets rid of this. So I got b by itself, which is what I was looking for. I want b all by itself. And so I can't subtract 45/2 from 7, but I can subtract it from 14/2, because 7 over 1 times 2 over 2, 7 times 2 is 14, 1 times 2 is 2, 14/2. Okay, so 14/2 minus 45/2. Again, you got to have integers. You got to know how to do integers as well. 14 minus 45 is -34. So I got -34/2, and that is basically, nope, I'm sorry, -33. I'm not good with numbers. Just kidding. Once in a while I make a mistake, just like everyone. And it's not even 33, it's 31. And now I feel really embarrassed. 31 halves. Okay, so negative 31 halves equals b. So I put this into this equation where b is. And so here I am at y equals 9 halves x minus 31 halves. This is the equation of the line passing through these 2 points. The equation is written in slope-intercept form. Now, I could have made that a whole lot easier if I had just figured out and gotten a little bit better numbers so you wouldn't have had fractions, but I think it's really good to, at this point, to understand that you're never going to be able to get perfect numbers, and it's not going to work out perfect all the time. You're not going to always end up with whole numbers. You might end up with something goofy looking like this. And if you're confused about integer operations, like if you didn't know how to subtract 45 from 14, 14 minus 45 is 31. If you didn't know that, then, well, like I didn't, then you need to practice that a little bit. And that's what I'm doing now. Now I'm going to introduce a new thing called point-slope form, okay? And let's see if I can erase this, and just a moment here. Hey, it worked. How about that? So we're going to talk about point-slope form now. Point-slope form. And just to review, we got the slope intercept form of the equation of a line, and you know what that is. That's y equals mx plus b. We've got the standard form in the last video. Standard form is ax plus by equals c. And I don't know if I made it clear before, but the a, b, and c are capitalized. You know, this is not little a times x. Uppercase and lowercase are very, very important in algebra or in geometry, so try to remember that. But ax plus by equals c. These are integers. That's why they're capitalized. Like, notice this is a little m and a little b, so they don't have to be integers. All right, and then the point-slope form. Okay, the point-slope form of a line looks like this: y minus y1 equals m times x minus x1. That's what the point-slope form of an equation is. Okay, so I'm going to add that here, point-slope form, and that is y minus y1 equals m x minus x1. Well, what's this y1 and x1? What are you talking about here? Well, here's how this works. Suppose I have a line, and I want to know what the equation of this line is, but I know the slope of the line is -2, and I know it passes through one point. Okay, I don't know what other point it passes through, but I know it passes through the point 3 and -4. Okay, so the slope is -2, and this is the point that it passes through. Well, aha, I've got x1, y1. So I'll call this x1, and I'll call this y1. And so now using the point-slope form, again, I'm just plugging in the numbers. Y minus y1, well, that's y minus a -4, equals m, which is -2, times x minus x1, which is 3. Okay, so y minus a -4 would be y plus 4 equals -2 x minus 3. Now this is the equation of this line written in point-slope form. You say, well, why would I do that? Well, let's try this equation in slope-intercept form. Convert it to slope-intercept form. That's pretty easy. I go y plus 4 equals -2x. I'm using the distributive property here. -2 times x, -2 times -3. So -2x, Negative 2 times 3 is a positive 6. So negative 2x plus 6. And I'm not there yet, so I subtract 4 from both sides. And I have y equals negative 2x plus 2. This is the equation now in slope-intercept form. Same values. If you graph this one or if you graph this one, you're going to get the exact same line. It's the same relationship between x and y, the same linear relationship. But this is in slope-intercept form. This is in point-slope form. Okay? So, a couple other things. Parallel lines. And I'm going to move down here. You remember when we did the thing that I showed you a while back on a couple of videos ago, I showed you a thing about, let's say y equals 2x minus 2, y equals, let's make that a different color here so I can graph different lines. Y equals 2x plus 2, and then y equals 2x plus 5. Well, let's take a look. Y equals 2x plus 5. 1, 2, 3, 4, 5 is my y-intercept. And 2x means 2 over 1, so there's my next point, 2 over 1. Or negative 2 minus 1, negative 2 minus 1. Because my slope is 2, negative 2 minus 1, negative 2 minus 1, negative 2 minus 1. And so, what I have here is this line, okay? And this is a graph of the equation y equals 2x plus 5, okay? And that goes like that. Well, let's see what else we have here. We can go to green and graph this other one. Y equals 2x plus 2. Okay. And there's 2x plus 2. And there's plus 2 is my y-intercept. Up 2 over 2, or over 1. Up 2 over 1. Up 2 over 1. Down 2 over 1. Down 2 over 1. Down 2 over 1, and draw my line, and what's true about this line? It's parallel to the first line. And then finally this one is minus 2, so there's my y-intercept, up 2 to the right 1, up 2 to the right 1. And making a long story short here, there is that line, okay? And so, what does that all mean? That means that if you have the same slope, the lines are going to be parallel, okay? Parallel lines have the same slope. You say, well, wait a minute, what about perpendicular lines? And get rid of those. Well, perpendicular lines, and I'm going to make it short and sweet here for you. Perpendicular lines, the slopes of perpendicular lines are negative reciprocals of one another. Okay, what does that mean? Well, it's really not as bad as it sounds. If you got, say you got a line here that's y equals negative 2x plus 4, and you want to know what the slope of the line is that's perpendicular to this. Well, a negative reciprocal, remember negative 2 over 1, the negative reciprocal for this is positive, because a negative of a negative is a positive. So negative reciprocal would be plus 1 half. Reciprocal means I turn this fraction upside down. So this line equals 1/2 x, and I can make it +4 or -2. It doesn't matter because anywhere I go on here, the line is going to be perpendicular to this line. So, all right, -2x + 4. Let's graph that. Make that green. +4 is my y-intercept. 2, 3, 4. There's +4. -2 means I go down 2 and over 1. Down 2 and over 1. Up 2 and over 1. Up 2 and over to the left 1. And so that's my, I've got a few points here, and I can draw that line. There's that line. Okay. And my imperfect arrows. And this one, I'm sorry I made that green. I should have made that blue. So let's call that's going to be a blue line. So -2 is my y-intercept. My slope is 1/2. So I go up 1 to the right 2. Up 1 to the right 2. Up 1 to the right 2. And so down 1 to the left 2. Down 1 to the left 2. And down 1 to the left 2. And we'll do that again. And there is, oops, and I just started off the wrong way. Alright, getting in a hurry here because I know I'm running overtime. Sorry about that. Thanks for hanging in there. You notice that these lines are perpendicular to each other. Okay, they meet at a 90-degree angle. And you notice that the slopes are negative reciprocals of one another. Okay, that's the whole point of this exercise. You're going to get some practice. Okay, and that means that when you try to write a slope of a line that contains a point and is perpendicular, let me tell you what I'm talking about now, and I'm going to go just 2 minutes more, and this is a 20-minute video, and if you guys are still hanging in there, God bless you. Say y equals 3x minus 2, and I want to draw I want to find the slope-intercept form of an equation that passes that is perpendicular to this line and passes through, and let's say 3, -4. Can we do that? Sure. First of all, what's the slope of the perpendicular line going to be? The slope of this line is 3. So the slope of the perpendicular line is -1/3. So using the point slope form that I showed you a few minutes ago, y minus y1 equals mx minus x1. x1, y1. Okay. Y minus y1 is y plus 4. Equals m, which is -1/3, times x minus x1, which is x minus 3. Y plus 4 equals -1/3 x. Negative times a negative is a positive. I'm distributing now. -1/3 times x is -1/3 x. -1/3 times a -3 is a positive 1. 1/3 of 3 is 1. Okay, and now all I have to do is subtract 4 from both sides. Y equals -1/3 x minus 3, and there is my equation in slope-intercept form of the line that is perpendicular to this line and passes through 3 and -4. And we'll have some more time in class to practice these and answer questions about this stuff. And I realize this video went way long, but I probably tried a little too hard to explain this stuff to you. Thanks for hanging in there with me.